Good afternoon, everyone. Thank you, everyone, for joining. It's my pleasure to welcome you all to the EDB Masterclass series. I'm Ashish Kumar Mehra, Country Head Sales at Enterprise DB. Before we start, a couple of key announcements. This session is being recorded and all the lines will be muted throughout the session. If you have any questions, please submit them in the Q&A panel and we will answer them towards the end of the session. We have reserved today's Q&A especially for our guest speakers. If there are any questions related to EDB or Postgres, please post them in the panel and we will reach out to you after the session. In this masterclass series, we are going to have eminent speakers from different walks of life come and talk to you. Today, as we celebrate the 25th year of the Postgres project going live, we have two very eminent people who are going to discuss how to ensure secure digital transformation. Now, let me introduce you to our speakers. Our first speaker is Saket Modi. Saket is the co-founder and CEO of Safe Security, a cybersecurity and digital business risk quantification platform company. Saket is part of Fortune Magazine 40 Under 40, Entrepreneurs Magazine 35 Under 35, and Forbes Magazine 30 Under 30 list. Our next speaker is Dave Page. Dave is Vice President and Chief Architect Database Infrastructure at Enterprise DB. Dave has been working with Postgres since 1998 and is one of the 7 core team members of the Postgres team. Welcome, Saket and Dave. Pleasure to have you as part of the Masterclass series. Before I hand it over to our speakers, let me take a few minutes to introduce you to Enterprise DB. We talk about Postgres. We know Postgres is one of the most popular databases, but the question that everybody has is why Postgres? Over the years, Postgres has been considered as the most loved and most popular database, and its popularity in comparison to other databases has been rising, which has led it to be winning a couple of DBMS of the Year awards. All this is good, but why did Postgres win? Why is it the most popular and the most loved database? The answer is simple. Whatever the workload, Postgres does everything, be it migrations, new app development, system of record, replatforming, cloud, containers, system engagement, all that can be done. And to top it all, it works everywhere. So you don't have to worry about where you want to deploy your implementation. And when we talk about Postgres, the name that comes along with it is Enterprise DB or EDB. So the question is, why EDB? Enterprise DB is the largest Postgres company, having over 300 Postgres technologists working dedicatedly on Postgres. We have a 91% customer satisfaction rating and have been recognized by leading analyst firms like Gartner and Forrester's. We work with thousands of our customers as partners to help them increase speed to market and reduce any database associated risk. Postgres started its journey in 1986, and EDB joined that journey in 2004. One of the things that we have been actively working on, apart from being one of the biggest contributors to Postgres, is to help build an ecosystem around Postgres. EDB also boasts of having the most Postgres experts amongst its employees. Our portfolio of products help you get all the flexibility and tools that are required for your enterprise deployment. We offer different plans based on where you are in your journey with Postgres. We've recently launched Big Animal, which is a fully managed database in the cloud by Enterprise DB. Taking all this into account, we built a portfolio of products and services which help you in your Postgres journey. You choose the database you need, the tools you need, and deploy them on platform of your choice with as much support as you need from Enterprise DB. A small sampling of our customers who we have been working with or helping them in their journey of Postgres. Now, with no further delay, let me invite our first speaker, Saket. Saket, in his talk titled "Everything Can Be Hacked," will now share some interesting things about how secure our digital footprint is and how secure we are. Saket, over to you.
Thank you, Ashish. I will start sharing my screen. Please let me know when you can see it. First of all, welcome everybody to the talk. We will try to keep the talk for the next 40 minutes and very comfortable in taking any question and answers that you would have along the way. And the talk which says everything can be hacked is actually not a true statement, because if you were to ask me, in my definition, my own bio in a very simple way is I'm a geek and a nerd. My own simple view is everything is hacked, but when I say everything is hacked, it generally is easy to counter, and therefore we say everything can be hacked. It's like a more softer form, because there's a very famous saying in cybersecurity which says there's only two types of people on the planet, or two types of companies on the planet: one who know that they've been hacked, the other who don't. And that's really the beauty of how and what things work. Today what we will see in the presentation is very little presentation but a lot of demonstrations. In other words, we will show you live how databases are hacked. We will show you how errors are exploited to go ahead and extract information from databases, and how that continues to be among the top three ways by which hackers intrude into very popular websites. And we will give a lot of such examples. We will not just talk about enterprise security, because all of you are spending an hour with me today. We'll talk a little bit about your personal security also, and we'll show you all of that live rather than just showing you stats and figures and numbers, because considering this is a relatively technical audience, we would like to not bore you with just the marketing of why cybersecurity and how cybersecurity, but actually show you what does it look like, not on the security side, starting from the actual hacks and then going towards security. So that's really the agenda. Let me share my screen and let me know when you can see it. Do you see my screen?
Yes, we can.
Yes. Yes, perfect. Thank you. So I'm not going to go full screen for a simple reason. I hope you can just read my screen. This is a much easier way of showing you my slide more in control. The topic really becomes, how do you quantify cyber risk to secure digital transformation, which I understand is a theme of all the talks which are happening out here. I'll give you something in 2021. Can somebody guess what is the common thing between all of these incredibly popular brands? Considering this, the audience probably cannot speak here, so I'm going to speak from the side of the audience. All of their databases were breached. And the numbers that you're seeing on the screen right now are the number of records publicly stated which were out in the open with hackers. And if you just add all of this together, you have 6.5 billion records which have been basically publicly exposed only in 2021. And why is this significant is because the total population of the planet is 7 billion people. And when you look at 6.5 billion records which are out there, it's almost a one-to-one mapping with everybody, barring the people who are just born, or maybe who don't come to the internet. Well, the internet population probably will be 3 billion, not more than that. But the point which is very significant is there's a lot of database hacks which happen all the time. And a lot of times those database hacks pivot into a lot of other things, whether it's doing a lateral movement between systems, doing a pivot to get to places where the hackers really want to get towards, or doing from systems coming to databases through middleware, etc., etc. We'll talk some of that about tactics and techniques that most popular hackers use, and then we do take it from there. But the message I'm trying to drive here is, again, the largest of the companies on the planet are still not foolproof when it really comes to protecting their customers' data. And these numbers that you're seeing are pretty significant, because as you can see, it's a lot of records which have been publicly exposed. There's a really nice line which Dan Schulman says, the CEO of PayPal, that we went from being Flintstones to Jetsons in the last 9 months. And that's the reason why obviously the usage of databases and the usage of anything and everything digital has shot up exponentially. And especially when you do that, for every database administrator, for every system administrator, the future looks very, very bright because obviously there's so much mission critical stuff that we've been running now because of the pandemic when you talk about the reliance on technology. When you talk about SQL and when you talk about databases, I'm going to jump into some demos. This was a very nice and a very cute joke, which I thought that when you name your son Robert single quote, and then you'd say drop students, and you go ahead and see that it's fairly simple to go ahead and just play around with names. And once you do that, you're able to see that the moment you enter the name in a normal database, you can actually do a lot of, I would say, a lot of wrong things on the database, which you're not intended to do. This is what the demonstration is, what I will be showing today as the first demonstration. We'll show you a live SQL injection attack, and we will actually teach that to you in a way where I'm pretty sure a lot of you guys will be able to replicate that when you go back. Because if you look at the OWASP top 10, which is the open web application securities list, every year they publish the top 10 reasons why hacks happen on web applications. You see application injections or database injections, SQL injection used to be number 1. It's still at number 3, which is a pretty high number in 2021, and it's been there forever. So if you think about ways in which you can inject queries into databases through the application layer, this has been one of the favorite attack vectors from hackers from many years, and it continues to remain that. And therefore, today, when we talk about real hacks of digital transformation, let's give you a real example of how websites get hacked. They call it SaaS, dashed, and breached. We'll do a live SQL injection demonstration for you right now, where we'll go to a demo website, and we will show you how you can actually shoot queries, and we'll walk you through line by line of what things are. Now, I do understand not everybody's a database administrator on the call, so some of you might not be with me completely, but we're recording the session, and I'm sure you'll get a copy of it so you can go back to it whenever you want. Nayan, my friend, who's more of a hands-on hacker than what I am today, or I used to be many years back, is going to help me in putting this together. So Nayan, if you can please share your screen.
Yes.
Sorry, somebody's saying something?
Yeah, Saket, I'm sharing the screen.
Thank you, Nayan. So we're going to use this public vulnerable web application called vulnweb.com. And it's a PHP page that we all know, and it's actually a PHP page of a shopping cart which is selling artwork. Now, this is by design, by design out there to be hacked, and that's the reason why we are showing this to you in a controlled environment. Obviously, this can be replicated in a lot of websites across the globe. As you see what's happening here, when you click on a particular type of art or an artist, you actually see what the artist is, and then you get some information about the artist. You can see the pictures that the artist has. All of that is obviously stored in the database, and you're able to put things together, right? So this is a normal PHP e-commerce page, which a lot of companies would be using as a structure. And this is using the normal MySQL database, using which you get all the inputs and outputs. Now, if you think about it, when you click on a particular a particular type of data that you'd like to see, you see on the top, if you click on a particular artist, you will be able to see it says artists.php question artist equal to 1. Now, for most of you who are proficient with writing programs, you understand what this means in a very simple way. This translates into a SQL query at the backend, which says select star from artists, where ID equals 1. And again, how do you know, Saket, the table name is artist? We don't. Will be some table name. So select some column from some table name where ID equals 1. And that ID equals 1 is what you saw as the URL. Nayan, if you go back and show them the URL, that artist equals 1 actually. So Nayan, if you can just copy paste artist equals to 1, just that part, just so that they understand what that looks like. So, in that particular, instead of where ID equals 1, and if you can just put that wherever you are going ahead and saying artist. So I'm sure all of you understand this, that whatever number we will enter there, instead of 1, if we enter artist equal to 2, we will be able to go ahead and get the data for the second artist which is out there. Now, can you go back and just show them what it looks like? So we all know, right? I mean, we've all seen facebook.com profile.php ID equals some number. It's the same thing. So when you said artist equals 2, you get the second artist's data, which is being extracted from the data. Very, very straightforward 101, going slightly slow so that people can be with me on what it looks like. Now, can I say using get or post parameters in this case, we are able to send some variables where there is an interaction that is happening with the database. Let us try to give an intentionally wrong variable. For example, let's just add a single quote, right? So if you add a single quote and press an enter, I hope you understand what happened. That percentage 27 is just the ASCII code of single quote, right? It says MySQL error, and it actually says that, you know, it is a wrong syntax, which I've got the moment I mentioned one single quote. Then can you go back and show what that looks like? So when you put one single quote, this is what you know, it looks like, right? When artist equals one single quote, and even if that is a string which is being put, or a varchar which is being put with 2 single quotes, the moment you have 3 single quotes, it will obviously give an error. So we just got an error, and the moment we got an error, we understand that, okay, this is good news. Why? Because I'm at least being able to inject variables directly into the SQL query, which is being run at the back end. There are ways to filter things out. And again, we'll not talk too much about exactly how to secure it, because we can take a full masterclass on that. But right now we are talking about how does the hack happen. So I've figured out that, okay, it looks like there is a conversation I can have with the database, just tampering the variables which are out there. That's good news. So I'll use this very popular tool. We can do it manually, but it takes much longer. We'll use this tool called SQL Map. So we'll type the query to basically shoot up SQL Map, and obviously you can download. It's a Git repository. It comes with Kali Linux also pre-embedded. So if you have Kali Linux as an operating system, this will, and that's a free of cost operating system you can download. You will get all the parameters, and, you know, if you type help, it will, obviously it's a Python file, so you can just download and run it on any system practically. So, you know, we'll use a couple of parameters there to go ahead and start to see how, now that the interaction is happening, let's try to see how we can see that actual data. So we'll just copy the URL, which actually works. So, and we just check that it really works. So we'll write Python 3 to execute this and SQL map.py, and then we will go ahead and simply enter exactly what we want SQL map.py to do. Nan, can you just put the whole just put the whole query, please. So we will go ahead and mention the URL and press an enter. And yeah, you want to get the list of databases which are out there, and that is the reason why you will put database out there. So then you want to just go ahead and press an enter. Great. So you see what we just did. We're just going to wait for a few seconds to go ahead and give you a perspective of exactly what have we done here. If you think about what we just did, we have used something called, there are 2 different types of SQL injection attacks that we are using here. One, if you'll see, it's time-based SQL injection, and the second is union-based SQL injection. So Boolean blind, time-based blind, and union-based, 3 of types, right? So if you want the manual steps, I can actually tell that to you, because the moment we figure this out, we use something called the union query between 2 different from statements, so select statements, and to get the 2 select statements, we basically need to know the exact number of columns on both sides. So just on the same, then if you go back to the actual URL, artist equals 1, and if we actually say, and just give a space and say order by 1, order by 2, order by 3, basically you're asking the SQL database to go ahead and order by, you're basically asking the SQL database to go ahead and sort the particular output on the column. So the moment it says I cannot order by a particular number, it basically means that that column doesn't exist. Order by 11 and then dash dash, which will be, you need to terminate the query, right? So the moment we will be able to do that, 11 probably is, there are no 11 columns, but if you say order by 1, you will be able to see what and how things are. Now, this is the individual steps by which you will be able to go, look at this, I got this, right? If I do order by 2, which is, I'm just trying to sort the data by the second column, which is out there, it will basically go ahead and give me some result. And as long as it keeps giving me result, I know how many columns are there. I'm trying to show you how hackers use errors. Just do order by 5 and then see if it's an error. Let's see if we get an error. Yeah, we got an error. So it's between 2 and 5. So let's do order by 3. So I'm simply, sorting it based on the number of columns, and 3 is there. And if you do 4, it probably will be 4 then. If I see an error, or do I get some data? Let's see. Okay, we got an error. So if you see, I was able to sort the number of columns till the 3rd column. And therefore, I know that in the select query, which is being used, it has 3 columns which are out there. So this is just a good explanation around how do you find the number of columns in the first select query, and then you can use union to actually find out, what are the names of databases, and that's why you use something called, union select information underscore schema dot table. So 1, 2, 3, which is the 3 columns, because, and you can say anything, and then from information underscore schema dot tables. Now we don't have to do it manually right now. It will take hours to do it. We'll go back to the SQL map, and this does it for you. So if you didn't understand anything I said, you don't need to understand. All you need to do is the URL, and the tool will do the job for you. I wanted to give you a little bit of a more hands-on of what's really going on at the back end. And we all know that, there is a by default schema, which is called information underscore schema, which is a database which always has the names of all the tables, all the columns of a particular database, and that's always there in MySQL. And then there is also an AccuArt, ACUART. It looks like AccuArt is a database that will be of interest to us, because that will have the data if we want the dump of all the users and what are they doing. So Nayan, if you can now deep dive into AccuArt, because I now know what is the name of the database that I would like to go inside. So I'd like to go into AccuArt and then find the name. You know how this works, right? You go with the database, and then you go with the tables, and then you go with the columns. So the D stands for AccuArt, because I know this, but now that I know the name of the database, I just want to know what the name of the tables are. Again, the way it's finding it out, it will use blind SQL injection. It will use the union query, and it will get the information depending on what time it is taking to respond to certain SQL queries. And you see, these are the names of 8 tables which are out there in the database. And it looks like the last table, which says users, is of the highest interest to us, because obviously this might have all the juicy information that we really care about. So again, we have the name of the database, and we have the name of the table. So we will say users, and now the next piece is obviously finding the columns. So let's find the names of the columns. And again, all of this is automated. If you don't understand what's going behind the scenes, SQL Map for you, as simple as going ahead and putting that together. So we just found the column. It looks very interesting because it's address, the card, the credit card, the email, name, password, username. So so now we can see whatever data we want. So whatever data we want to be dumped, Nayan, if you can go ahead and dump all the data in that particular table for all the columns, or just the table, because it'll dump all the data. Just give it a few seconds, it'll run the, and this is all live, obviously, on the demo website. And here it is. You actually have, you look at the email, it says email, the credit card details, it's fetching the information. Then it's slightly small. If you can just zoom it in. Yeah, this is perfect. Now, something very interesting, by the way, it looks like, there can be a customer which is protecting the data, and you can always hash the data and store it. So this product actually allows you, or this tool allows you to go ahead and very, very simply crack certain hashed passwords or hash text which is out there, and you can use various dictionary based attacks, and you can use rainbow tables to go ahead and crack some hashes. As all of you know, you can never rehash something which is already hashed, but it basically use matching stuff. And that's the reason why salting the data that you store in a particular place becomes extremely important. I'll just pause here for a second. The one, again, Nan, if you want to add something to this out here, just in terms of, what else can you do with the data that you're getting here?
Yeah, so sure. I will just add here that not just this, but we can, using this tool, it is so powerful that we can actually dump everything like the database accurate. We can just simply give a command like we previously did. We don't have to actually go table by table. If you know that the tables are not that big, or you just want to target everything. So what you can do is you can just do hyphen hyphen dump hyphen all, and it will throw up everything inside the database, from the tables like pictures, like card details. Now it's again asking for the same thing that we did, because the table had some of the passwords. So it already asked you that, do you want to crack the hash? So things like that. So it will just dump everything. And what finally can it give is something like this that the hacker can make for himself, right? So there are tables and there are entries. So we can compile everything. Also, we can let the SQL Map tool itself to do that for us. So it's creating a CSV file for each and every table it's getting from the database. So you can see that there is this path, and we can go inside that path. You can just go to, I'll just take that, copy it, and let's just go to that directory, and I'll do ls. And you can see that for every table we have a CSV file, and for the CSV file we can just open it on our Libre software or whatever you have.
Yeah, so it'll create a CSV file is where Nan is showing this to you, and basically very ease of access and ease
of access. Yeah,
user experience is actually pretty good. And you can imagine there's a full-fledged industry called carding, where hackers go inside e-commerce websites and dump all the carding details, and then sell it out for $2 to $3 per card and things around that. So that's just one good example of where things are. You can do much more. You can actually execute on terminal commands once you get an access to the database, because depending on the privileges of that particular database on that particular systems, you can actually do some degree of remote code execution via that database and SQL injection also. So there's a universe of things that can be done. I'm conscious of the time. Anything, Nan, that we've missed that you would like to add? Otherwise we can move on.
Sure. So we have covered the SQL injection attack, and also the different attacks inside it, like the union-based injection and everything. So on a good day, an attacker may find it like using the SQL map tool, or easily do it using a union-based injection. But the injection attack is complex, and tools like these, which are openly available online and do actually give us the steps to perform how to do that attack, is actually dangerous. And so it's like a whole tutorial on it. So anyone can just install it and start doing it. So that's the complexity and the criticality of this injection attack and the SQL map, the use of SQL map here.
Yeah. Thank you. And that's something which is very, very important. And thanks for sharing this. I will move on. I wanted to give you a live example of how this works, and you can download this tool. It's a free of cost tool available. It's a Python script, and it's a pretty popular tool where, in fact, there's a full-fledged tutorial on each type of SQL injection attacks. I remember the days when I learned. It's called the Dhakkan training, and it actually calls you a Dhakkan and makes you teach every kind of attack. And the thing that I get excited about is most of the SQL injection really happens based on the errors that you get. And that's the reason why, basically filtering out the errors and making sure it's sanitized when you go ahead and give the output for as a database administrator becomes so critical. And this is like a very, very popular way in which a lot of data is extracted. And as you can imagine, not just the URL, it's both get and post parameter. You can use something like Burp Suite, which is a proxy between the web application and the web browser. So every kind of variable which is going back and forth, you can go ahead and you can intercept that, and you can do a lot of things on those lines. And there are a lot of extensions for the same. But again, I've been told that you have both kinds of audience here, so I want to keep it technical and at the same time not go very deep. And as you can imagine, this is something that we do for a living. So very, very happy and comfortable to go into it as deep as you want offline. So I'll go back to my screen sharing. Let me know when you can see it. And
You can see it.
can you see it? Perfect. So this was like a good example of how hacks happen for databases. And by the way, there is no database which is immune to hacks like these, right? As you can imagine, what we're trying to do here is really exploit the errors or exploit the issues of how a database responds to user input. And a lot of that evolve with time. Which one is better than the other? No comments there, because every database has its own vulnerability. It's about awareness. It's about the person who's the administrator, which is far more important than which database it is in most cases. So that's there. And I just hope you understand that the breach in the database and the data leaking out is not just a point in time, oh, a few records went out, right? It actually touches anybody and everybody, whether it's businesses, and this is an actual calculated number from Gartner, that there's an average 9% drop in the global annual turnover as a result of a data privacy crisis that businesses face. The board obviously is very, very, very worried. In fact, this was again a study which was done by FTI Consulting, which says 40% of the boards by 2025, not very far from now, will have a dedicated cybersecurity committee. Most of them have a risk committee right now, but they'll have a dedicated cybersecurity committee. The CEO, in GDPR laws, and probably very, very soon as data protection law in India also, the CEO is personally responsible for the database and the security of the database for their customers' data. And the Indian Data Protection Act has actually taken it one step further. GDPR restricts it to the executives of the company. The Indian Data Protection Act, at least the way it's proposed right now in the House, is going to make the board of directors personally accountable for a data breach. So it is, somebody was telling me this really nice analogy that that punishment is almost as harsh as if somebody does a horrendous murder, and you can be behind bars with no questions asked. At least the existing proposed law for data privacy in India is that harsh. So just letting you know, it's a pretty big deal. And as you move forward, a lot of database administrators will be under in a lot of scrutiny of saying, please make sure our databases are really, really secured. And examples like the one which I gave you, and that's one, there are like hundreds of such examples of how databases are hacked. You definitely want to go ahead and take inputs and really buckle up your security skills on that side of database and SQL injection and other things which are out there. Obviously, CISOs, which is Chief Information Security Officers, and look at this stat. This is very funny. 24%, so 1 out of every 4 Fortune 500 CISO changes their job once in a year, right? So it's almost like the attrition of the whole industry in Fortune 500 is 24-25%. It just talks about how volatile the entire security industry is. And obviously CFO, CMO, cyber insurance, etc., etc. I mean, anybody and everybody, if you think about it, gets really affected. And especially because databases store the crown jewels of what most companies do as business. So at that time, when the database gets hacked, it's technically the business getting hacked. It's not like a back office ERP got hacked and the internal billing was down for 2 days. So it's not like a crazy crisis. Today, customer interactions are happening mostly using the web or the mobile. And obviously the common thing between all of that is a database where you store the actual crown jewels and the information which is out there. So that's just, where we are, and just giving you a perspective of, that it is not just a database got hacked. It is almost like shaking the foundation on a lot of places of how the company operates. And that's really the reason why JP Morgan Chase CEO Jamie Dimon a couple of months back on CNBC was saying, my number one worry is really cybersecurity, because I don't know what is the security posture of my company. And even then, that's after spending $1 billion. They spend $1 billion every year on cybersecurity. Now, I know this statement sometimes means, oh, does that mean that Like it's impossible to get secured, and even after spending $1 billion, he's not secured. So what's the point of spending any money? Well, I'm not saying that. That's the other extreme. I don't think either extremes is good. So there's a middle way always, which is more balanced and which is more in harmony with what is required for the business. So that was about the enterprise and databases, and I wanted to share that a little. But I also do understand that just for you to know that more than 92% of enterprise attacks have a people element in it. In other words, that there'll be somebody or the other who would get an access through some employee of the company because of the criticality of the accesses that they have or information that they have. It becomes a pivot in most cases, if it's not direct, to do lateral movement and get to the final destination where the hacker intends to get to. In other words, people security is very, very important. And obviously the most popular form of people security, which gets breached all the time, is through phishing. So we'll give you a live demonstration of something which is I mean, I know a lot of you have heard of it, and some of you in your organization see it all the time, but a lot of you don't get to see how does a phishing page really get prepared and how easy it is, again, to use a few frameworks. It's super simple, right? Right click on netflix.com's login play. You get the whole source code. All you have to do is host it on your server, and the get post parameters where somebody's, entering the password, just direct that and submit that form on a text file that you've hosted on your web server. And it's really that simple to go ahead and get the password. You want to make it slightly more advanced, simply send that or relay that password to the actual post parameter of netflix.com/login, and guess what, you would be able to log in, and the person doesn't even realize that they actually filled in a phishing form which is out there. So we will show you a little bit of the back end of how phishing works, because the front end I'm pretty sure most of you are familiar with. So I'll stop sharing and I'll go back to my friend Nayan. And if you want to go ahead and share your screen and just show a little bit of how easy it is for a person today to go ahead and actually prepare a phishing
Yes.
and make things happen. And by the way, more than 70% of the hacks that happen on people actually happens on phishing. And this was a Sophos report. So it's just something which we should know, at least as technical people, how the backend works. It just makes us more aware for the front end. Nayan, do you want to just take it from here?
Yeah, absolutely. So I'm here again with another demo on phishing. And this time we are going to use a tool which is called Black Eye. So phishing is an attack where we are actually targeting a person, a human, and exploiting the vulnerability of the lack of awareness of that individual. So what we are going to show you here is how easy for an attacker is to actually set up a tool, learn how it works, just run it, and actually execute the whole phishing attack, where he will actually get the credentials of the victim who was not aware of the whole phishing scenario, who was not actually interested in looking into the whole phishing email and checking if it's actually authentic. So let's just do that. So here I am on my attacker's machine. And this attacker's machine is a Kali Linux machine installed with lots of penetration testing tools and all. But what I have installed here is another tool called, again, the Black Eye tool. Here, what I will do is I'll just start executing the blackeye.sh. Is just a binary, and I'll just execute that. And the scary part here is that this tool provides a lot of options to actually execute a phishing attack on. So we can create a scenario of Instagram, Snapchat, and so many. But for demonstration purpose, we are going to select the Netflix. So it is a very famous streaming platform, and a lot of people are always interested in getting free subscriptions. So we know that people actually do that. So the tool is really easy to use. We have to select an option, which is Netflix
and by
option.
the way, don't to interrupt, but just a quick point. As you can see, these are options, right? If it's about knowing your attack, your potential victim also, or who you're attacking. The person is very popular on Instagram. You can maybe make an Instagram page. Netflix is very popular in India, so we're going to just
absolutely.
yeah.
Yeah. So we are going to set up the tool according to what it's asking for from us to actually give in as an input. So I'll just enter my IP address.
It's because it'll start a web service on this
Yes.
IP, and then you're hosting a page out here.
Now, so the hosting is done and the tool is now waiting for the victim to open the link. So this is the link. Now, what the attacker did here, the attacker has already sent an phishing email to our victim, which looks something like this. So a really well-crafted email here from Netflix that the attacker victim received from the attacker's end. And we deliberately have highlighted some of the problems that there are with this email, but the again the lack of awareness of the victim caused him to actually forget that there are like mistakes or things like that, and the only thing the victim is interested here is free subscription for 6 months, that too for 6 months. So what the victim didn't notice was, if you can just look at the left hand side bottom corner, the IP address is not of Netflix. It's the URL is not of the Netflix. It's an IP address. It's an IP address of the attacker, which on which the attacker is waiting. Now, let's just say that the victim is really in a hurry and clicked on the link. Okay, we are on the right track as from the attack victim's perspective. And the victim has to just enter the email address and the password. Let's just say victim@gmail.com. And password will be a safe password, which is really long, uses special character and everything, right? And the next step will be to sign in. So again, the second part of the lack of awareness, the victim was not able to sign in and was also not aware that what happened with his credentials. So he was not able to sign in. That's the first part. But let's just see what happened on the attacker's end. Let's just go back and we all can see what happened. So by first click, the victim, first of all, just reveal the whole identity of the browser information, the user agent and things like that, and the IP address also. And on the second part, when the victim entered the account information, the credentials, the safest password the victim used, all was exposed to the attacker. So this the level of ease here can be seen clearly from the phishing attack, and the level of awareness required is we can say they're not that much, because we have to be aware that's the part of being safe in this kind of attack. But just the simple fact, the lack of the simple fact caused the victim to actually lose the credential, and actually maybe the second problem that arises from here is the common practice of the people to actually use the same password on multiple platforms, right? So maybe this password is also the password of some other critical account.
This is so, Nayan, I'll take it up. This is very helpful. Thank you for this.
Sure.
Because we are obviously running out of time. So what we will do is that this is a good example of how this works. The last 1-2 minutes that I want to just take to make sure we wrap this up. You obviously might be thinking that, oh, by the way, this was an IP address. So if you get a link and you click on an IP address, it won't, you will be very, very smart and you will never go ahead and enter your passwords there. So let me just show you the last part of the demonstration where I'm going to search for Deepika Padukone, which is my favorite actress on Google. And you see, I get almost some many millions of results. And again, I'll go to Google and I'll again search for Deepika Padukone and press an enter. It says Deepika Padukone did not match any documents. This sounds very, very, very crazy, right? I just got millions of results. And if I type Deepika Padukone again, I didn't get anything. The reason this happened is because this double E that I was using was actually not an English E. This was a Russian E. It's called an IDN homograph attack. The reason I'm showing this to you is that I can set up Netflix.com with the E as not English E. So I'd use this E, which is which is basically Cyrillic, and I basically use this E. I copied this, and every time I pasted it, there's 2E and this last E is this thing. So I can, as you know, we can register domains in so many languages. So we can register a domain, take a SSL certificate. So it'll actually show HTTPS with the green sign. It'll show netflix.com. It'll show login with a password. And you can see with that, we'll be able to put things together. So anyways, look, this is what I wanted to share with you guys. And just talk about that. Even on the personal side, there's a lot which happens, and there's a lot for us to be secured. They say tactics without strategies and is the noise before defeat. This is Sun Tzu from The Art of War. So making sure that you've got the right tactic in place is very, very, very important. And therefore, making sure you're realigned with today's normal of the real modern age attacks which are going on, and understanding the new trends becomes super, super critical. And that's, by the way, one of the areas where, what we do as Safe, just for a minute, when you talk about databases, this is our actual product, which is called Safe. We actually go to databases, and we do it for everything on cloud and on-prem assets. But if you go to databases, we actually provide the risk analytics score based on all of these controls which are out there, and put that together to give one score of saying, okay, what is the risk posture of every single database in your environment? And based on that, what controls are failing? And these can be configuration controls, vulnerability controls. It can be EDR controls for the server, et cetera, et cetera. And then you obviously get to simulate that. Okay, if I patch these 3 controls which are failing, what is the simulation that happens? The reason I'm showing this to you is there are a number of such tools which you can use to monitor the way your application performance monitoring as APM. You similarly have security performance monitoring with companies like ours, which go ahead and show you not only every database, but every EC2 instance, every S3 bucket, everything which is an asset gets a dynamic safe score, which rolls up based on the department-wise score and shows you, where you are and how you are, and put things together. So anyways, that's what I wanted to share for just a quick minute in terms of the future ways of how protection happens. And if you want to go ahead and double down on security, that I can assure you is something which is definitely one of the most important aspects of your career that's going to be as a database administrator, as a system administrator in the near future. We obviously have a lot of white papers, et cetera, on how do you secure, measure and manage and mitigate cyber risks. This is one of them. You can do a QR code scanning from your phone if you want. But that's all I had to share with you today. I will hand it back to you, Ashish, in terms of, I know I probably shot over time by 5 minutes, so I apologize for that, but that's where we are.
Thank you, Saket. This was very, very insightful, interesting for everyone. So thanks a lot for doing it. To the audience, please keep your questions coming in. We have a Q&A with Saket after Dave's presentation. So thank you once again, Saket. As we move along, we are going to have a small survey which will be available on your screens. I would request you all to take 1 minute and answer all the 4 MCQs. Everybody should be able to see that right now. Please submit your responses. Another couple of seconds. Perfect. Moving on. Thank you, everyone. Thanks for submitting. Now, as we move along, we've got our next speaker is Dave Page. Dave, in his talk, Security Considerations in App Development, will speak about what are the key things that need to be taken care of from a security perspective while developing a new application. Dave, over to you.
Thanks, Ashish. Good afternoon, everyone, and thank you to Saket and Nayan for the talk and the very impressive demos. So I have a fairly short talk today, and I know we're running out of time, so I'll skip over the who am I slide. I think Ashish covered that quite well. So data security, why? Well, so the obvious answer is business confidentiality. We don't want to lose the competitive advantage. We don't want our competitors to learn our trade secrets or really as anything about what we're doing. You know, we want to keep all our company data secret. But you know, as we look into this some more, we start to think, well, we've got legal obligations to keep data secure. So Europe, GDPR that Saket mentioned. USA, they have a ton of different regulations around data protection. So HIPAA, which covers health care, FCRA, FERPA, COPPA, and so on. Saket also mentioned the new data privacy bill in India that's currently, I believe, working its way through the House. If you're doing things like payment processing, then you need to comply with PCI regulations, for example. But perhaps most importantly of all, the moral obligations. You know, we need to protect our employees' privacy. We need to protect our customers' privacy. If we don't protect our customers' privacy, you know, they're going to lose faith in us. They're going to stop doing business with us. And if we don't protect our employees' privacy, then, well, they're not going to work for us anymore. And they're going to leave. They're going to go to the competitors, and we're going to be out of business pretty quickly. One of the things we've got to really consider, though, is what forces us to do this, and that's of course the legal obligations. On the right-hand side of the slide here, you can see a list of some of the biggest GDPR fines so far. Now, GDPR in Europe allows fines of up to 20 million euros or 4% of your worldwide turnover, if that's larger. So you can imagine the fines for messing up data security can be absolutely huge. $746 million there for Amazon Europe. 225 euros. 225 million euros for WhatsApp. So these are not numbers that you can just write off. They're real fines that will cause real problems for a company. So how can we approach this? This is a very short talk. This is very high level. So I'm not going to go into details about how you can use features like row level security in Postgres or those sort of things. You know, we could do 2-week-long training sessions to cover all of this and still barely scratch the surface. But we're going to look at a methodology, if you like. So we call this AAA, so authentication, authorization, and accounting. The first part of this is authentication, obviously. We want to ensure that the people that we are providing data to are who we think they are. So in other words, when I log into a system, the people running that system really want to make sure that I really am Dave Page, and I'm not somebody pretending to be Dave Page. There's various ways that we can look at this. And again, this is not an exhaustive list. This is just some of the things that we think about. We want to protect the server. So if it's a private database, VPN, so we're only allowing expected users in. Firewalls. In Postgres, the pghba.conf file, which can limit access to specific users on specific hosts to specific databases. We can also set up authentication requirements for connections in pghba.conf. So we can specify that a connection for Dave Page to this particular database must use Kerberos authentication or must use Scram SHA-256 and so on. There is an argument that protecting the server can also be considered part of authorization. To some degree, I consider it part of authentication because you're expecting the user to come in on a particular network in a particular way. So that's part of knowing who they are, because they've come in the way they should do. Moving on from the server, we've got to be really sure of the user's actual identity, regardless of where they're connecting from, whether they're coming in on the VPN or whatever. Simple stuff, strong passwords, multi-factor authentication, Kerberos or Active Directory. If you're running in a large enterprise, then using tools like that really helps you both improve security and ease management of users and policies across the organization. Number one rule, never ever have shared user accounts or credentials, ever. That was when I first started at EDB. I actually ran the IT department for a while, and the very first policy I wrote had that as the first thing on it. If we ever found out anyone had shared their credentials or created a user account on a system that was shared in any way, it was immediately deleted. Authorization. So this is where authentication is knowing who your user is. Authorization is understanding what they're allowed to do and making sure that they can only do that. We tend to suggest to users, system administrators, developers, whoever, follow the principle of least privilege. So only allow users to access what they need to do their jobs and nothing more. I always suggest making use of roles in Postgres and role membership for ease of management. Assign permissions to group roles to do specific tasks. In Postgres terms, those could be on databases, whether or not they can connect, whether they can create databases, create objects. On tables and views, things like select, insert, update, and delete permissions. So always set those on group roles. As soon as you try setting specific permissions on individual user roles, then management becomes a nightmare. Because every time somebody joins the team, leaves the team, you've got a whole load of changes to make and cleaning up to do. Instead, what you do is you create and set up the permissions on those group roles. And then when a new member of the team joins, you just assign him to that role or her to that role. Row level security is something you might want to consider, so you can restrict access to subsets of data. So, for example, in a hospital environment, patient notes might be restricted to the medical team that are responsible for that patient. So people in other parts of the hospital have no access at the lowest of levels, the database level, to that data. And if they can't access it at the database level, then they can't access it at the application level either, of course, assuming that your user roles and so on flow from the application to the database. Data masking and redaction is another technique that you might want to consider. So this is quite common, for example, when you're dealing with payment processing systems. You might have saved a user's credit card number for convenience, so the next time they log in and try and buy from your store, they don't have to enter it again. But when a member of your team looks up that user's information, there's no reason to show them the entire credit card number. So we'd mask it. We'd maybe only show the last 4 digits. So if the customer rings up with a problem making a payment, we can confirm just for those last 4 digits that it looks like they're using the right credit card. Accounting. This, in my experience, is where most people tend to fall over, and this sort of gets thrown to one side and forgotten about to some degree. But it's critically important. Audit everything. So perhaps most importantly, this helps you detect breaches as soon as they happen, because they probably are, as Saket mentioned, 2 types of companies: those that know they've been hacked and those that don't. This helps you be in the first category. And that's kind of important. You have legal obligations under GDPR and other legislation to report breaches in a timely fashion to authorities. You also want to minimize the effects of the breach. You don't want somebody breaking into the system, downloading a bunch of data and then realizing, well, hang on, they've not detected me yet. I've still got access, so I can download some more. Or maybe I can expand my attack and start hitting other internal systems within the organization. You want to shut that down as quickly as possible. And auditing and alerting on those audit logs help you do that. They also help you understand what happened. So when you're doing an analysis of an attack that happened, a post-mortem, if you like, you can use that audit trail to help understand how that attack was orchestrated, how that attacker got into the systems. And that can then help you plug those security holes. So you can figure out, well, there was a problem here. They used this to get into the system initially. So I can fix that by fixing this SQL injection attack. And then, right, they went from there and they escalated their privileges by doing X. So we can fix that in this way. So the audit trail, it's really critical for a number of reasons, both from detecting those attacks, enabling you to report them promptly, stop them as soon as possible, and also understanding what went wrong and making the changes to stop it all happening again. So we're on to the summary slide already. I've kind of rushed through this because I know we're very pushed for time. But my suggestion is always make use of the AAA model. You know, understand who your users are, make sure that you verify with utmost certainty that they are who they say they are. Only grant them the permissions that they actually need to do their job and nothing more, or to use the website and nothing more. And track and audit everything so that you can understand what happened if something does go wrong and you can take appropriate action. I also always say security is like an onion. It's a bunch of layers. So we don't just look at security from the perspective of the database. We've got to look at multiple layers within the database. So everything from the encryption that we've used on disk, through to the row level security and the table level security and the ability to connect to the database and the requirements to use SSL to connect to the database, and the way the application authenticates with the database, and the way the application protects against SQL injection and so on. You know, there are lots of these layers, and a security system requires all of these things. You know, you can't just think of it as one small part. You've got to look at it right the way throughout your application stack and build up that security as you go. We've really only touched on the topics. I mean, I've been talking for what, 10 minutes, if that, probably. As I said, we could do 1, 2, 3, 4 week long courses on all the different aspects of this. So the idea of this talk is really just to give you some ideas of other things to go look at. Application security, virtual private clouds. If you're running in the cloud, how can you configure those? How do you set up the security around them? If you're on an internal network, can you segregate different parts of your network, of servers and your infrastructure using VLANs, for example? Should you use SE Linux so that you're enforcing at the kernel level where a connection can come in from and what privileges that connection will have? So mandatory access control rather than discretionary. At-rest encryption, the data on your disk, is it encrypted? So if somebody physically steals the disk drive, can they then get at the data? In-transit encryption, you know, when that data is traveling across the network, if somebody can mirror a switch port, can they listen in? Or are they just going to see a whole bunch of encrypted data across the network connection? The physical security, where is your server located at? If you're running in the cloud on one of the big providers, you can be fairly certain that it's a SOC compliant data center. They've been through lots of audits. There are very strict security measures in place on the sites where they're hosting their servers. But if you're running in a small business, a startup, and you've got some servers in your office, in a server room, what's to stop somebody breaking in and stealing those? You probably don't have anything like the security that you would at a cloud provider, but you might still have legitimate reasons for having bare metal machines on site. So you need to think about the physical security of those. And then when you start diving down into the database itself, you know, I've mentioned things like row-level security and access control lists, so insert, update, and delete permissions, for example, on tables. But there are many other things you can start looking at, like security definer functions, which allow you to run a function with the privileges of the owner of that function rather than the of the user. That's kind of like the Postgres equivalent of sudo, and it is, when used correctly, is a very, very useful tool for securing certain types of data within the database. Security barrier views are another thing that you might need to look at. These are views which are designed to stop subqueries and things like that from inadvertently leaking data to an outer query, where the user that's using the view wouldn't necessarily have direct access to that data from the subquery, for example. So there's many other things that you should study, and that may or may not be appropriate for your specific environment, your specific requirements. My point is, this is a huge topic. It's a complex topic, and it's very important that you get it right for moral reasons, for legal reasons, and for business reasons. So I know we've got some questions coming in for Saket, which is brilliant. Some additional resources there that may be of interest. We've done a number of best practices in security for PostgreSQL webinars in the past. You can still access those on our website. I wrote what I think of as a mega blog, which was originally, I think, 6 parts, and then our marketing team decided they should all be one big blog. That covers the whole end-to-end security in a Postgres application as best you can in a blog that size. So it tries to cover all the different things that you should look at, and gives lots of different examples. And then EDB Labs, so our CTO team here at EDB, where we do a lot of our research and development and so on. We have our own blogs where you can go read about what we're doing, which includes some security and AI and benchmarking and things like that. So that's all I have for you today. So thank you very much for listening, and back over to Ashish.
Thank you, Dave. This was very, very helpful, and I can see a lot of questions coming in. Since we are over time, I'll just pick up 3 to 4 questions which have come from the audience. Dave, the first question is for you, and Saket, if you would want to chime in, is there a book that you would like to recommend on Postgres security?
I don't actually know of any particular books on Postgres security. I mean, I tend not to work from one single source of truth, if you like. I Google, I read, I try and assimilate and do research from lots of different places and come to my own conclusions based on what I find, rather than relying on one thing and saying this is the Bible, if you like, of security. So no, there may well be some very good ones out, but I don't know what they are.
Fair enough. Thank you, Dave. Saket, a question for you. Companies spend millions of dollars, and when what you showed and Dave showed, that still a lot of data is stolen or compromised. These are companies who've got a lot of experts working for them, but they're still not able to save their data. What can individuals do at their level to secure their data? Any tips, any points out there?
Yeah, that's I would say that's a pretty loaded question, as you can imagine. Now, I would say there are 2 things which are very important. One is, for every individual, there needs to be a psychological shift on how they look at the internet. A lot of times when you go on a WhatsApp call which says end-to-end encrypted, you actually think that nobody can hear that. That's not very true. There's a lot of, devil in the detail kind of stuff which is out there. And it's not just the content, it's also about the metadata. It's also about at the point at which it's encrypted, before that there can be some bug. And basically thinking and having a psychological view of anything and everything that you're doing can be potentially hacked is very, very, very important, which I think we take for granted when we use the internet, when we use our devices or applications. So that's one. The second piece is awareness, right? I mean, we go to the school and college for like good 10, 15 years to really get the basics of life on how we do things right. We spend very little time in really understanding how Facebook works or LinkedIn works or an application works when it comes to security, or even a framework works. So I would say awareness is very important. Where do you go for awareness? I can, because I get this question in almost every webinar I go to. We actually have a free of cost app. You can download that. It's called Safe Me. It doesn't take any permission. It has hundreds of cybersecurity training videos for 3 minutes, both in English and Hindi. It has questions. It has videos like, how do I secure my WhatsApp? How do I secure my Android phone? How do I delete my Instagram account? So doing it the right way in videos less than 3 minutes is something that you can get there. And that'll have a lot of technical answers of the right way of doing things. So again, assuming that things are hacked when you're doing things, and spending time on awareness in learning the right way or a more responsible way of behaving on the internet. I think these are the two things I would definitely recommend there. Ashish.
Saket, can you just repeat the name of the app once again for our?
It's called Safe Me, SAFEME. We can have somebody from my team write the
If you can just type it in the chat for the audience, that will be very good.
Yeah, sure. Safe Me. And it's both on iOS and Android. We'll just give the link also where you can, I'll just give you the link, no problems.
Fair enough. Thank you very much. One last question, and again, Dave and Saket, you both might want to chime in. Tracking is great, auditing is great, but it comes at a cost. Where do you draw the line? Any experiences that you would like to share on that point?
So I would look at the fines that you can get under GDPR and is it going to cost you anything like those could be? But yes, it does obviously come at a cost, but typically these things are not overly expensive to deal with. I mean, when you're talking about the network level, your routers, your switches, and so on, can typically spit data out into our syslog, or you can ingest it into one of the databases that's designed for log analysis and so on. When you're building your web application, you can use triggers on tables quite easily just to log data changes into a history table. So, a bit of development time, if you're logging the changes on any one table, it's relatively trivial to write a generic trigger function that you can use to do that. And then you're talking about storage. And let's face it, storage is cheap these days, right? It's not expensive to get a few terabytes of storage, and this audit logs are typically mostly write-only data, so you don't need anything horrifically performant or anything like that. You just need a table space that's maybe got a few drives in RAID 10 that could then potentially store billions and billions of audit log records from your application. So I don't consider it expensive, especially when you start looking at the size of the fines you might get for doing it wrong.
Fair enough, Dave. Thank you. Saket?
Yeah. So, this is like, I have a lot of places where I know very little. This is one of the areas where literally, live for we do everything for a living over this. There's a way to look at enterprise-wide risk management, and to say how much is too much. And you should never start by saying how much money is too much, because that's not the right way of looking at, I'm talking enterprise risk right now. The right way of looking at it is, what is the acceptable residual risk after all the controls that you've gone ahead and applied within your organization? Because when you look at the risk, and risk needs to have a metric of dollar values, not ABCD, not red, amber, green, not highly likely, medium likely, not likely, etc., etc. There are mathematically proven data science backed ways to convert an incident or convert a failing control across your EDRs, vulnerability scanners, etc., into the real dollar risk of your company. And when you know those, when you don't know those, use those metrics to present to your board and your CEO and your CFO and say, like today morning, I presented to a very big law firm, which basically said, this is the X $100 million risk that you're sitting on. Now you can do three things to the risk. One is mitigate, the second is transfer, or the third is accept. In other words, if you want to mitigate, there is certain amount of money that you need to invest, which will say, this is the amount of money. If I invest it, this much risk will come down. And it'll come down from say 100 million to 50 million if I invest $2 million. But according to the law of diminishing returns, every time you invest $2 million, it won't come down by 50. It will actually come down disproportionately as you keep moving forward. So the second thing you do is transfer the risk, and that's where cyber insurance underwriting comes in. So you buy cyber insurance, so you're transferring the risk, and even after that there'll be some residual risk and you accept the risk. So that's the right way of looking at risk management, because there's never a number. No matter what number you give, it might be large, it might be small. It should be your risk appetite is what you need to go ahead and define, and once that's defined in the right way, that is where the question around how much money to spend on cybersecurity should typically come. And the last 30 seconds, typically the thumb rule for large companies that we've seen, especially on the North American side, financial services, it ranges anywhere between 8 to 16% of your IT revenue or IT budget. And when you look at manufacturing or even companies in India, we've seen, as little as 1%. The upper limit will probably go to 6 to 8% on their IT spend of how much money should you spend on cybersecurity. Ashish, sorry, long answer, but as I said, it was a pretty loaded question.
This was very, very important, Saket. Thanks a lot. Thanks a lot for sharing. Unfortunately, we're totally out of time. I know both you and Dave have other meetings to go to. So thank you very much. Thanks a lot for sharing your wisdoms. Thanks for sharing your experience with the audience. For the audience, we've taken down the questions. We'll try to answer them later. We'll directly reach out to you. But thank you everyone. Thanks a lot for joining. Thank you, Dave. Thank you, Saket, for your time.
Thank you, Ashish, for inviting me. Thank you, Dave. Pleasure being a panelist with you. Cheers.
Thank you. Likewise.